There are two major cell types of the nervous system. Those include neurons and neuroglia. We're going to start off with neurons first. So what do neurons do exactly? Well, their role is to help communicate. And to communicate, there are three major parts. So think about when you need to communicate, such as using your cell phone. To communicate, you should be able to do three things. One is receive input or receive calls or messages. Two, you should be able to process it. And then three, you should be able to send out the message or the phone call. So neurons have three main parts to do this communication also. The cell body, which is shown here in the center, this is the part of the neuron that integrates all the information. Now the information is received through the dendrites. So the dendrites get the input. These are the branch-like structures that surround the cell body. And then the axon does the output. So it sends the message away from the neuron. Now you have about 100 billion neurons in your brain that are all communicating with each other. So let's take a closer look at the neuron in a histological slide. So here we have a real neuron in here. So this is the cell body right here. These are the dendrites coming in, and this would be the axon leading out of that neuron. Then here's another neuron cell body, and that's the axon leading out of that neuron. Let's go into a little more detail about the dendrites. So I told you that dendrites receive the input. When they receive the input, we call it the impulse, it sends it towards the cell body. So here you can see the dendrites, and then the input would go towards the cell body. Now I've shown you here three different neurons, and each neuron looks slightly different. You can notice that this one has the least amount of dendrites, middle amount of dendrites, and then look at this one has a lot of dendrites. Remember, they receive the inputs, so the more dendrites you have, the more input. So this cell over here is going to be able to receive the most inputs. And these are going to vary based on what the neuron needs to do and where it's located. Another interesting thing about dendrites is that they can change throughout your lifetime. So there was a study done by McKay and Turner in 2005, and they actually traced a neuron in a rat from birth throughout the first month of its life. And what they did was they took the rat and they injected a dye into the neuron, so they can visualize the neuron here, and you can see all the little dendrites right here. And this is at P0. P0 is when the rat was just born, so the 0 day. And they traced that exact same neuron to the rat at 30 days. So that's about 1 month in. Again, the same neuron cell body, but look at what happened with the dendrites. There was numerous amount of dendrites, so clearly we had a lot of dendritic growth. Now, a rat at 30 days is the equivalent of about a human at 2.5 years. So start to think about a child at 2.5 years old, right? Think about the terrible twos, the toddlers. Think about the behavior that you start to see in a 2-year-old. That's really different. You might notice that they're interacting with their environment more, they're constantly asking why, they're moving around, they're touching things, they're exploring. So think about that. The toddler has lots of dendrites. It's able to receive a lot of input and a lot of stimulus from the visual world, which is why you start to see the toddler interacting so much with the world, which sometimes gets nicknamed as the terrible twos. Now, what about adults? Are all of our dendrites set? No more growth? It turns out that even as an adult, your dendrites can still change. So they did another study with rats, and this time they took mature adult rats. And this is one neuron, and you can see here lots of dendrites. And this was in the control situation. And then what they did was they took that same rat, followed the same neuron, and they put that rat in a stressed situation. So what does it mean to stress out a rat? Well, it turns out rats are very social animals, like humans. So they took the rat, they isolated the rat away from its rat playmates. They took away the ability for the rat to exercise, so basically just was down to the bare minimum, the basics, and that stressed the rat out, and you can see it in his behavior. Now, in the stressed rat, look what happened to the dendrites. Notice there's not that many, right? So stressing out the rat actually caused the dendrites to reduce, so reduced dendrites. So, of course, if you think about it, this neuron is not going to work optimally because it can't receive the full input. So think about yourself, right? You're probably stressed out studying for anatomy and taking your classes, but you don't want your neurons to be in this state because they're not going to work optimally. So a question I often get is, well, let's say you're stressed out, you lose your dendrites, can they come back? Fortunately, yes, they can come back. So they actually put this rat back into its regular control condition after it was stressed out, and they found out that the dendrites did grow back. So don't worry if you're stressed out now. Once summer comes or once you have a little time to breathe, your neurons' dendrites should recover. All right, let's talk a little bit more about those axons. So remember, axons, it sends the output, or in other words, it sends the information away from the neuron's cell body. So the information we call the impulse. So here is the cell body, and then this arrow in red is showing the information being sent down the axon of the neuron, and then it's going to basically reach the dendrites of the next neuron. So we keep saying this word impulse. So what the impulse is, it's something called an action potential. So the strict definition is that an action potential is an electrical impulse across the plasma membrane of a neuron. So what it really is, it's like an electrical flow of information. So imagine like information flowing down a wire through your computer, right? Or going through a wire from your TV. That is information being sent through the wire. That's similar to the electrical impulse getting sent down an axon. It's just charges going across the membrane going down the axon. And this electrical impulse is the information being communicated. Now let's talk about how fast this action potential can travel. Well, think about how fast electricity can travel. So it can go up to 350 miles per hour, so pretty quick, which is good because a lot of the reactions you have, for instance, if you're in danger and you need to react quickly, you want this information to move quickly. All right. So where's this information going? Again, it's called the action potential, abbreviated AP, and it travels down the axon. Now let's say you want this information to go to the next neuron. Now, there's this synapse between the two neurons. So the synapse is the communication site between the neurons. The synapse is actually an empty space, so the neurons don't actually touch each other. So this is really important because think about how electricity travels. As long as it's in the wire and that wire is connected to another wire, right, then it's fine. The information keeps flowing. But if you have two wires and a gap between them, like air, the information is going to stop. Or if you have a gap between the wire and your computer, right, if it's not plugged in, again, the information is not going to flow. So again, the synapse is like that empty space. It's like air between. So the action potential can't flow across the synapse. So instead, we have to use something called neurotransmitters. So neurotransmitters are physical chemicals. They're chemical molecules, and they actually help relay the message across the synapse to the next neuron. And then the next neuron can convert that into another action potential and send it on to the next synapse, where you get more neurotransmitters to go to the next neuron. So neurotransmitters are going to become really important as a part of our communication. And in fact, when we talk about drugs, right, over-the-counter drugs or prescription medicine, a lot of drugs actually target neurotransmitters. They help increase or they reduce your natural amount or action of your neurotransmitters. So a little more terminology to help us understand how neurons communicate. Remember, this is the synapse right here. So the neuron in front of it we call the presynaptic neuron, because remember, pre means before, so it's before the synapse. The neuron after the synapse we call the postsynaptic neuron, because post means after. So again, the synapse is in between.